Okay, good evening. Hey, good morning. This is Professor David J. De Los Reyes. Okay, it's already November 12, 2023. The time is 12:02 a.m. Okay, my topic for this morning will be the continuation of my uh, long video format topic, trigonometry, and I am now on lesson number 21. I am now on lesson number 21. Okay, let's proceed. The subject matter for this morning will be trigonometry, lesson number 21, and the title of the topic is example problems on obtuse angles. Obtuse angle is actually, we have discussed that one the last time around. The four variations of problems that involve obtuse angles. And the main problem is actually how to get the values of the 6 trigonometric functions with the proper sign in each of the 4 cases. Oh, yeah, 4 cases. So for this morning, I will give you example problems illustrating those concepts. Okay, let's try to bring out example number 1. Find the sine of 225 degrees. If you do not have a calculator, okay, and if you try to bring out the what you call this value of sine of 225 degrees, okay, you've got a problem. But if you know the technique on the so-called obtuse angles, we could find for the value of an angle that is more than 90 degrees. Okay, let's try to bring out the solution. If we try to graph the angle sine, 225 degrees, with reference to the 0 degree line, 225 is more than 180, right? So it falls under quadrant number 3. So this falls under case number 3. Okay, the angle lies on the third quadrant because it is greater than 180 degrees, right? And it is less than 270. So it is sure that it lies under the third quadrant. If we try to take the sine of this, okay, without using the calculator, we must have to compute first for the reference angle of this alpha here. The reference angle of alpha is actually the angle which is measured with reference of the 0 degrees, and it is terminated by the given angle, right? The reference angle is actually the 0 degree or 180 degrees to compute for the value of beta. So in here, if we try to take the resulting value of beta, beta will be 225, okay, minus 180 degrees. Why is that so? Because beta plus 180 is equal to the given value of alpha. Beta plus 180 is equal to alpha. So if we try to compute for beta, beta will be 225 degrees minus 180, and that will be 45 degrees. So the value of the reference angle is 45 degrees. So if we now try to place our solution, sine of 225 degrees will now be equal to, let's try to bring out first the sine. For an angle to fall under the third quadrant, the vertical side is a minus and the horizontal side is a minus. Horizontal side, it is to the left of the 0 and 90 degree line, and the vertical side is actually below the 0 and 180, so it's also negative. This negative and negative. So if we try to take the proper sign of a sine function is actually opposite over hypotenuse, right? The sign of the opposite side is actually minus. And the sign of the hypotenuse, it's always a plus. So a minus and a plus, okay, it will be a minus. A minus. Meaning to say the sine of 225 degrees should be equal to, we place now the negative sign, and this negative sign emanates from this. We take the ratio minus over plus, so it should be minus. So the proper sign of 225 degrees should be minus. Okay? So I place it here. Sine of 225 is actually negative sine of 45. Sine of 225 is actually the negative sign of its reference angle, and it should be 45 degrees. The sine of 45 degrees is 0.707, but according to our sign, it should be negative. So the value of sine of 225 degrees will be negative 0.707. And if we try to verify our answer, we'll just display 225 here, then take the sine function. It is negative 0.707. So without even using the calculator, we could compute for the value of sine of 225 degrees with the proper sign, that is negative 0.707. Okay? Got it? Okay, example number 2. Example number 2, find the cosine of 321 degrees. So the number 1 step on how to bring out the solution, we plot this 321 degrees. 321, it is actually greater than 270, and it is less than 360. So the angle lies on the fourth quadrant. Right? So this total angle here is 321. Right? Sorry for that one. 321. And the reference angle should be this one. Right? The horizontal side will be a plus. Right? Because this thing here got a horizontal component and a vertical component. This one is to the right of the 0 and 90, so this is a plus sign. Okay, the vertical side is downward. It is below the 0 and 180, it's negative sign. Of course, the hypotenuse is a plus. Okay, let's try to compute for beta. Beta is just actually beta, okay, plus alpha is equal to 360. Right? So if we try to compute for beta, beta will be equal to 360 minus alpha. So beta now will be 360 minus 321, and the reference angle beta will be 39 degrees. So this is 39 degrees. So if we now try to compute for the cosine of 321, the original alpha, okay, let's try to bring out first the proper sign. Cosine is actually adjacent over hypotenuse. The adjacent is plus. The sign of the adjacent is plus. So this is plus all over a plus. A plus over a plus is a plus. So the cosine of 321 degrees will be a plus cosine of its reference angle, cosine of 39 degrees. Okay, we are sure it is plus. I place it there, cosine of 321 degrees will be equal to plus cosine of 39 degrees, and they should be equal to. The proper sign should be plus, and cosine of 39 degrees, okay, 39 cosine, right, it's 0.77, right? Okay, actually if we hit, if we try to place it, we'll do the value of alpha. So we know that this value here is, meaning if we try to take the cosine of 321 directly using the calculator, it should be this, or it should be plus cosine of 39 degrees. Okay, 321, we take the cosine, okay, it's 0.77 plus, right? Or you could actually bring out 39, you take cosine, it will still be the same. So meaning the cosine of 321 degrees will be plus cosine of 39 degrees, and they are both 0.77, 777. Okay? A cosine on the fourth quadrant, the sign is plus. Okay? That's it. That's the proper way. We determine the sign by using this is plus over a plus, a plus over a plus, so this plus. So cosine of 321 will be plus cosine of 39 degrees. It's not minus, it's plus. Even by using the calculator directly, it's 0.347. Okay, example number 3. Just watch out, guys. There are some problems on the short videos that are coming out like this. They are giving obtuse angles, and you are asked to find the trigonometric function value. It depends on what they will be asking, right? It could be sine, cosine, tangent, cotangent, etc. But the proper way on how to get the proper sign, the one we discussed the last time around. Okay, try to draw the figure, designate the plus and minus signs. Okay, and when you try to bring out a function, okay, take note of the proper sign, like this one here. Cosine is actually adjacent over hypotenuse, a plus over a plus, so it should be plus. Okay, right? Okay, that's it. Oh, example number 3. So we got an example problem under quadrant number 3. This is quadrant number 4. Okay, let's try to bring out an angle that falls under the second quadrant. Find the tangent of 135 degrees. If we try to bring out the graph, 135 is this one. And the value alpha is 135 degrees. So this is beta. Okay? So beta plus alpha is equal to 180 degrees. So if we try to compute for beta, it should be 180 degrees minus alpha. So this is 180 degrees minus 135. It should be 45 degrees. So this is actually 45 degrees. Okay? So if we now try to take the tangent of this, okay, tangent of 135 degrees. Okay, let's try to bring out the proper sign. This horizontal component is minus. This vertical component is above the 0 and 180, so this should be plus. The hypotenuse is always a plus, right? So if we try to take the tangent of 135, tangent is opposite over adjacent. It should be this side here over this, right? This is a plus. The adjacent is minus. A plus and a minus should be minus. So the proper sign for tangent of 135 is actually minus. Okay? Tangent of 45 degrees. The reference angle we have computed. Therefore, tangent of 135 degrees will be equal to negative tangent of 45 degrees. The proper sign should be minus, and this minus here actually was derived from this. It should be tangent is opposite over adjacent. A plus over a minus will be minus, so this is minus. And if you try to bring out your calculator, tangent of 45 is a special angle. It should be 1 because sine of 45 is 0.707 and the cosine is 0.707. So tangent will be 0.707 over 0.707 or it's 1. So the tangent of 135 degrees, and this is equal to, okay, negative tangent of 45 degrees, and this should be equal to negative 1. If you try to check this, just display 135 here, then press tangent. What will come out should be negative 1. It's negative 1. Okay, it's negative 1. It's negative 1. Okay, that's it. So at least we now know how to compute for the value of a trigonometric function if it falls under the third quadrant, fourth quadrant, and the second quadrant. Okay, good evening or good morning from Los Angeles. This is Professor David J.